Welcome to another video on my Raspberry Pi 2 which is connected to network right here, serial cable and a band cable. Serial cable for communication with laptop to see how the Raspberry Pi boots and to start VNC service, and network to use VNC service, virtual network computing. Using band cable coming to this breadboard with some electronics, LED, light emitting diode, resistor, button, fischertechnik LED, phototransistor, motor, and that is what it is about, because the Raspberry Pi runs Ubuntu Linux as well as the robot operating system, and the robot operating system uses nodes for sending messages to control things. That's what it is about, control electronics and whatever else. Last time I managed to get messages finally over, but the last thing that I could not accomplish was shining this light with now charged batteries to the phototransistor and then get the difference. Do I see a light or don't I see a light? So that's the main focus now. Can I see that or can't I? So let's see the software and find out if it works. Alright, and this is the software side, with on the left side the second VNC desktop, source code with the nodes ready to run, control motor, red LED, this one, phototransistor right here, and on the tablet right here the FT LED, so that is this one, as well as the Macintosh, the Apple to compile stuff, and yeah, it's a dark display because backlight gives in or up. Anyway, let's start everything. ROS core already runs. Control motor, and you can immediately see that the motor starts running. Red LED runs phototransistor, and off screen I also start now the fischertechnik LED, which you also see working, but that's not what it is about. It is about this light, and in this terminal you should see the difference between the phototransistor or not. And right now it's not quite alright, because I see phototransistor all the time. This is 1. Now that is not what I anticipate. So why does it see everything? Alright, let's shine a light. Because I should see 0. And this is the wire for the red LED, so that is working. This one is the connection to the motor, so that one is working. Then how come that the fischertechnik is giving 1 all the time? That should not be. So if I disconnect here, what happens? Okay, let me put the motor a bit aside. Oh wait, I can do it much safer. I just disconnect this wire. And it still says phototransistor gives a 1, which is obviously not the case because I'm not shining on the phototransistor. So this is a weird thing. Three is okay. Let me remove the necessary light, and I will cancel it and do it again. Still the same. And shining on it, I should have a 0, and that's clearly not happening. So what's the difference and why? And checking the wiring, it gets clear, because here I have of course a wire from the voltage divider to the GPIO, which is, by the way, pin 13 and not 15. So which GPIO I don't mind, but it is pin 13, and GPIO, okay, so be it. Which one? Save. Anyway, fixed the wire right here, and now it correctly tells me that this photoresistor has not been lit. So that is what I'm going to do now. And now I should see somehow that the phototransistor is working. The light is strong enough. It's the I have to indicate which one it is, which gives the light. Alright, let me take the cap off. Again, shining the light. And it doesn't work. Seemingly. So this is a bummer. This is not what I had hoped to do or to accomplish. What I can do is replace the phototransistor and see if I can reach another result. Let's do that one. So I replaced the phototransistor right here on top. So let's do it again. See if that actually matters. Winding nicely. Yep. And that, unfortunately, has no effect. So whatever is going on, this is not the way I anticipated it. How can I do it better? This is reading it. If digital 2 is 0, which is now the case, and a bit wider, here photo becomes 1, photo becomes 0, so that is alright. What I can also do is making sure that it is 1 or 0. So I put a line here. ROS info. Photo is, and this works the same as this one, so this should be working. No. And paste, so that I can actually see that it is the way it is. And here the same. Photo is 1. And that I actually want to see that it is the way it is. Yes, cout says photo is. Alright. Right. And compile. Alright, and on the Mac where I want to compile everything, so catkin make. And there should be only one thing to make, which is the photo transistor file. So let's just wait and see what happens. Can take a bit, but usually with one file to compile it should be quick. And yes, what was meant to be a very short video, well, with wiring out of the socket and maybe a faulty photo transistor, you never know. And this is saying note. Is that an error, or is that, if it compiles fine, it should be alright. The question is, does it compile fine? It takes quite a bit, and I don't want to rush it. Still going on. Yeah, these are not the most fun time to watch. I suspect it ends in an error then, but who knows. Compiler error, alright. Then I will have to change something, obviously. And I will do so off screen a bit, and then do again. and I changed a little bit in the code. I replaced ROS underscore info by cout, and as you can see, this compiles just nicely. So I also did stop with Ctrl C the other node. So let's see how this runs out. So with this little change, replacing ROS info by cout, let's see if it really matters, if it really works out. And photo is 0, clearly seeing. And yeah, well, this is not a phototransistor, is still there, so it doesn't really matter what I did. But also assigning the value to photo is also important. But even with this phototransistor, it doesn't do anything. Not a little bit. Can I change this? Perhaps by an oscilloscope value and measuring it, or by putting an LED to it and see if that one lights up. More things are possible. But I think this is for now the end. Alright, so unfortunately I still haven't been able to change the result of this. Despite replacing a phototransistor, I really have to measure the value now. But well, time is limited, so it will be next time. For now, thanks for watching. If you like this video, please subscribe to my channel to give the video a thumbs up. Leave a comment or suggestion, very much appreciated. You can also follow me via Instagram and Twitter, and you can show your appreciation by making a donation via either PayPal or Wired, and you can also become a patron, and depending on the pledge you make, may have your name mentioned on my website and with my videos. All information under this video, and please follow the link to my website to see much more. This is going to be continued. Have a nice day, and bye bye.